Hello and welcome to the Telecom TV Summit on Open RAN. I'm Guy Daniels, Director of Content, and coming up now is our discussion on Telecom Silicon. We want to find out how custom silicon is being used or should be used in open disaggregated networks, what optimal hardware is needed to get the most out of Open RAN, and what innovations are required for Telecom Silicon. And above all, what will be the benefits to operators? Well, let's find out what our guests think, and I'm delighted to introduce Olivier Simon, who is Director of Radio Innovation at Orange, Harpinder Matharu, who is Senior Director, Strategy and Technical Marketing, Wired and Wireless Group at Xilinx, and Adil Kidwai, who is Head of Product Management at EdgeQ. Hello everyone, very good to see you all. Thanks so much for taking part in our very first panel discussion on Telecom Silicon, a subject that I know we'll be hearing a lot more about in the months ahead. So first of all, why do we need optimized specialist silicon for telecoms infrastructure and specifically Open RAN? And how would Open RAN performance be impacted if we don't have this optimized silicon and hardware? Olivier, let me start the discussion with you because this is a subject that you and I have spoken about before.
Hi, Guy. Yeah, the first thing I think to say is that the telecom machines, the base stations, have from the start had specialized silicon. And the reason is that you have different layers, different type of processing inside this base station, and especially the low layers needs very high computing power, and this computing power is growing from technology to technology. So as an example, when we go from 4G to 5G, the computing power that is needed, especially with massive MIMO, is much higher than what we have with 4G. So the challenge is at the same time to have good performance in terms of power consumption, in terms of footprint as well, and at the same time to have good flexibility, especially with Open RAN. So with Open RAN, what we think will be the good combination is that the higher layer would be managed in a very flexible way with some more generic silicon, I would say. But the low layer executing, very intensive calculation would be helped by some more specialized silicon. And the result of that is, especially in the front of power consumption, to have a much better efficiency, keeping at the same time the flexibility that we need for Open RAN. And if we don't do so, what will happen is that at the end we may come to a situation where the performance level and the power consumption will not be as good as traditional system. And it's really key for operators that the Open RAN reach at least the same performance level and even better in the future.
Thanks, Olivier. And we're going to pick up on some of those points you've raised a bit later in our discussion. But for now, Harpinder, let me come across to you for your views as to why we need dedicated silicon.
Right. So there are some functions within the wireless infrastructure that require specialized silicon. For example, radio, digital front end, beamforming, acceleration in CUDU for L1, for crypto functions. We do need specialized silicon for these functions, and these functions are continuing to evolve from generation to generation. So 5G has added a lot more functionality in these areas. So just to give you an example here is that so when we moved from 4G to 5G, in 4G, the mainstream deployments were using a 20 megahertz 88R LT system. And now when we come to 5G, we have mid-band massive MIMO systems, which are the mainstream deployment, either 32 TRX or 64 TRX, and they are 100 megahertz. So if you look at the change in the specification from 4G to 5G, now the same silicon has to now address from 40 times to almost 300 times more functionality within the same constraints that we have for silicon technology. So we at Xilinx were looking at these challenges, and for our 7 nanometer Versal technology that we were building for beamforming, we had to add specialized compute functions, what we call vector engines, to address the beamforming requirements, which were growing at over 300 times more complexity. So this kind of indicates why we need to have specialized silicon to address some of the evolving requirements. And also, while we are building these silicon, we also have to anticipate as to what new requirements may emerge in next 2 to 3 years, and make sure that we have sufficient headroom to address those requirements. For example, in beamforming, there is also a lot of work happening where we are trying to do cross-layer optimization with the scheduler using AI/ML techniques. So we need to have compute to really address those requirements as well, and that's what we see we have been doing. And likewise, the ecosystem will have to continue to invest in specialized silicon to address emerging 5G use cases and requirements.
Thanks, Harpinder. Adil, if I could just turn to you, do you agree that Open RAN is really driving the need for more specialized and dedicated silicon?
5G is vastly different from 4G, right? I think that is established in the market. 5G is bringing new capabilities, novelties, which were never conceived before in the previous generation, like 3G or 4G. 5G workloads are vastly different, right? 20, 30, 50 times, depending upon which use case you are targeting about, right? So there's a lot of compute requirement for 5G as compared to 4G. The second point is, let me give you a thumb rule, right? At EdgeQ, we follow this, 50-50-50 postulate, what we call, right? 50% of the base station power goes, base station spend, right, goes into power consumption. Okay, 50% of the power consumption goes into the baseband processing. And if we were to save that 50% power, we could reduce the total cost of ownership, TCO, by up to 50%, right? So this is a 50-50-50 rule for a typical base station economics. Now you can imagine how important power is and how important it is to create a silicon or create a solution which can cater different 5G needs, right? One 5G application might require 5G to be a very fat data pipe. The other 5G application might require the 5G to be very low latency, right? So there are vastly different applications of 5G, and the power consumption and the cost of ownership is going like tremendously high as compared to 4G. All these things together have basically point us in the direction that we need to have dedicated silicon solution for 5G, not run 5G on generic processors as basically have been run in the past.
Now, bespoke silicon is phenomenally expensive. You've got foundry costs alone are huge, and we're talking many millions here. Is it commercially viable to design and make bespoke silicon for Open RAN? Harpinder, is it a viable option? And if not, is there a compromise here?
I think that this is a very good question, and certainly it is capturing industry today in the sense that what we see, the value proposition and the economic rationale behind doing custom ASICs is getting challenged as we are moving to smaller geometries, where because of the escalating costs and complexity and also the development time. And oftentimes, we do see that tier ones who drive significant volumes, they can afford to do custom ASICs, but they are also challenged in this space because they have to go through a 3-year cycle of spending another custom ASIC, and certainly this is not affordable for broader ecosystem. So what we believe within Xilinx is that adaptable SoC is the best approach, where you have combination of ASIC standard cell based hard IP with adaptable fabric that can accommodate emerging, evolving algorithms or requirements or use cases. And that way we can create a system that can be upgraded, and we can increase the longevity of those systems, plus also whatever IP, whatever design we are building on those silicon can be prolonged. And just to give you another example, what we have done within Xilinx is that we have come up with this new RFSoC DFE product, which basically marries the best of the two worlds, where we have ASIC hard IP gates married to our adaptable logic. And by doing so, what happens is that not only ORAN ecosystem can get the benefit of custom ASIC, but they can also adapt their algorithms and can differentiate, can innovate, and prolong the life of the systems that they're developing by having a ability to upgrade hardware within the field.
Adil, let me ask you a related question here. Going along with it, with the cost of silicon, what silicon are we talking about? As Harpinder just said, the solutions he's putting out, and you're putting out solutions as well. There's a very long list of types of silicon, from CPUs to GPUs to ASICs, what have you. That there seems to be new silicon coming along all the time. What specifically are we looking at for dedicated telecoms silicon, and especially silicon that's geared towards Open RAN?
So there are certain functions that need to be done in 5G infrastructure silicon, right? For example, 5 acceleration needs to be there. Encode, decode needs to be there. Like timing circuits, front haul termination, compression, decompression, all these functions need to be monolithically integrated into one silicon to deliver the 5G in a complete and holistic way, right? Now, what we are developing at EdgeQ is the first and foremost, RISC-V based processing for 5G, which is very malleable. So it's a very highly integrated, completely software-driven 5G base station on a chip. So we took upon ourselves to take basically the RISC-V processor and extend the custom instructions to provide 5G functionality at a cost and power point of Wi-Fi, right? So now you ask me, what are the different functions that are that need to go into the silicon, right? So of course, 5 acceleration, acceleration for layer 2 and layer 3 functionality as well, right? For example, crypto functions, networking processing unit. More and more as we go into this era of this 5G, we also see a strong need for artificial intelligence, to use artificial intelligence in scheduling algorithms, for example, in finding out the interference that is coming to the silicon. So it's going to be an amalgamation of a lot of functions, right? Physical layer functions, as well as layer 2, layer 3 functions, as well as networking functions, as well as artificial intelligence. So it's, fortunately or unfortunately, this is going to be very, very complex. And that's why these functions together cannot be run on a general purpose processor. Coming to the previous question that we were discussing 5 minutes ago, why we need a specialized silicon? Because just so many components, so many functions are being packed into this one device to cater the 5G market. So that is kind of the need for a specialized silicon, which combines all these functions into one.
Thank you, Adil. And Olivier, let me come to you now. What's your views on this? What is it that we really need what do you need as an operator? What do you need to see in specialized silicon?
Actually, I think the answer is a bit more complex than selecting only one type of silicon, because there are different use cases. Let me take an example. If you're building a private network, generally for this private network, you will have a small number of base stations. And so you may be a bit less sensitive in terms of the cost of the RAN, because a big part of your cost will be on the core network. But you need very high flexibility, because you need to really custom the way the radio access network is working to the demand of your customer. And in such case, maybe you can pick up something very flexible, like a CPU, maybe FPGA, maybe with some acceleration, but with something quite generic like GPU. And in such case, then you can really leverage the software layer in order to be very flexible, to adapt to your customer needs. On the other side, if you take the example of a very large urban network where you have thousands of base stations, All of them must be really efficient. They should accommodate a large number of customers, very large throughput, and so on. And in such case, then you need probably something that is more specialized, kind of ASICs doing a number of functions that must be executed in a very efficient way. Of course, you lose a bit of flexibility when you do that, but you are more efficient. So as a conclusion of this question, I would say that there is no really single approach. I think we will see different kind of silicon in the coming years in the Open RAN domain. Some of them would be for, I would say, small volume market, very flexible, very software oriented, and some of them will be more for more standardized type of market, like mass market with very high volume. And in such case, you need something to be very, very optimized. So we will see both at the end.
Great, thank you, Olivier. Thanks everyone for your comments on that topic. Now, we've talked about speed, we've talked about accelerators, but we're looking further than that really, because we're also seeing intelligence. We're seeing growing interest in service-aware silicon that can work in tandem with the software higher up the stack to optimize performance, especially as we move towards more software-based networking. Adil, let me come to you first for some thoughts about what we're seeing with this particular approach.
Yeah. As I mentioned before, right? When we think of 5G, right, we think about three C's, as we say, right? Connectivity, compute, and the cloud, right? 5G is bringing a lot of new features to the game, right? New capabilities like new spectrum, new features like ultra low latency, right? Massive MIMO. I think we talked about that. Millimeter wave. To harness all this goodness, right? It requires an understanding of both hardware and software, right? Now, as these capabilities grow more and more, there is a lot of need to put more intelligence into the solution, whichever solution you provide, right? I think we were just discussing how 5G is basically need to cater a small enterprise as well as need to cater a big macro, right? So we felt the need that we need to merge 5G and AI together. AI needs to help 5G in terms of many different functions. For example, spectrum monitoring, scheduling, right, or coordination of different base stations. So at EdgeQ, we kind of natively merged 5G and AI because at the base of these two very big technologies is some basic mathematics, which is very common. So we kind of identified the need of having an intelligent 5G from day one, and which kind of resulted in where we are today, where we have combined artificial intelligence along with the AI, such that 5G can cater these different use cases for which we are talking about, like enterprise, fixed wireless, big macro, and all these different use cases.
And Harpinder, what's your views on service-aware silicon?
Yeah, so I think that I would like to talk about what ORAN is trying, and some very good work is happening in terms of near real-time RAN RIC controller, RAN intelligent controller. And the whole point behind that is to kind of open up the infrastructure where within the CU, within DU, within radio, we have service-aware intelligence that we are basically doing a lot of telemetry and gathering data that can be leveraged to fine-tune the performance of the same cell sector as well as within the network, overall network, to coordinate with other cells. A good example is that there's a need for doing dynamic carrier configuration in radio, or also dynamic spectrum sharing. So there is, within the radio, there is sufficient intelligence as to how the channel and how the radio is performing that can be leveraged. And then when we come to the beamforming part of it, where we are doing, we basically are taking spatial streams and mapping to antennas. There again, there is a sufficient intelligence that can be optimized in conjunction with the scheduler that is running in, say, in a virtualized RAN and DU. Basically, this can kind of open up some of the APIs to the applications that are running at, say, at the RIC level that can optimize not only that specific cell, but also it can coordinate with adjacent cells as well as other operators who are basically having their equipment in that particular geography. So there is a tremendous capability that is possible with this specialized signal. It's just a matter of tapping into those data sets to really create more optimized operation of the cellular networks.
Thank you. It's going to be interesting to see how this goes. We had a panel discussion yesterday that focused on the RIC, and with the RIC enabling X apps and R apps, it's going to be interesting to see how Silicon can help support those efforts and that innovation. I want to move on, if I can, to an area that was mentioned earlier in our discussion. That was around power efficiency. There is a need generally within our telecoms networks for better power efficiency and lower energy usage. Olivier, could Telecom Silicon help us here?
Yeah, sure. There are many reasons why power efficiency is really at the center of this discussion. The first reason would be social responsibility. A lot of operators are committed to with their customer and with their regulators to have as much as possible improvement in terms of social responsibility. It could be inclusion and so on, but there is a very important green aspect. So this is one. Another one is about money. I can tell you that most of the operators are doing a lot of action, to maintain their OPEX at a reasonable level to stay competitive. The most difficult part of this is the cost of energy. All the large operators are spending hundreds of millions, if not billions of euro or dollars in this area. And the third reason is the bad news, is that the cost of energy is still increasing. So there is a clear case, a clear total cost of ownership case about optimizing the energy. For these three reasons, we need to optimize. So how to optimize? Of course, you can optimize by doing intelligent software. You can, for instance, push for efficient sleep modes that you can trigger either very short sleep mode that you can trigger quickly during the day when you have load. You can do some deep sleep mode that you can trigger maybe at night when the load is lower. But you also need some hardware efficiency in order to master your power consumption. And this is where silicon comes into play. Fortunately, we have been able to deploy additional frequency very often as operator without increasing too much our power consumption. And so far, the main reason has been that we have technology improvement in terms of power efficiency. Initially, it was more for the analog part, the power amplificators. And now with 5G, the most important part is the digital part. And specialized silicon enable, for the reason discussed already, to year by year improve this efficiency, and we are expecting that this improvement will continue in the next 2, 3, 5 years, especially because we have companies such as Xilinx today and their competitor investing quite a lot. I think they understood that it is a key part of what the operator will require in the next years.
Thank you. Harpinder, the whole world is faced with rising energy costs at the moment, and they are rising rapidly. I don't see them ever coming back down. So anything we can do to reduce our energy usage is obviously going to be very attractive to and beneficial to everyone.
I think this is a very critical requirement, and we at Xilinx see it in two aspects. The first thing is to optimize the power consumed by this specialized signal. But then the more important part of it is that we have to also optimize the performance of the PA. Just to give you an example, say for example, in a massive MIMO system, a typical 200 watt system that is getting deployed in the field today. So for this 200 watt to be emitted on the antenna, we are basically consuming close to 300 or 400 watt of DC power within the system, which is getting dissipated as heat, just because these PAs are running at 40% efficiency. So this specialized signal can also improve the efficiency of these power amplifiers, which is what is significant research area within the industry. We have now GaN PAs getting deployed, which can boost the efficiency by another 5 to 10%, and that brings significant savings. Likewise, if you look at the beamformer, and today in systems, we do see that operators are deploying systems which can support 16 spatial streams in the downlink as an example. But oftentimes what we see is that not all 16 spatial streams are getting deployed on a per slot basis of a wireless frame, which means that we are losing the opportunity to connect with more users at the same time. And that's where I think optimizing or cross-layer optimization with scheduler can help us to maximize delivery of useful information for the power that is being emitted on an antenna. So there are multiple ways we can optimize the power. So it's very important to have a balanced approach where we have advanced algorithms which will consume a little bit more power in the silicon, but will bring significant savings in efficiency of the transmission that we are getting from the antennas.
Great, thank you. And Adil, you're a startup. Adil, you represent a startup. How much of a factor is reduced energy usage for you?
A big factor, and actually, I wanted to contribute to this particular question. I want to take ourselves like few generations ago, 2G, 3G to 4G, right? In these generations, right, cell phones have been getting tremendously power efficient, right? Your iPhone or your Android phone, whichever one you have, you can see that these are very power efficient devices. They have invented new things like DRX cycles, as somebody was talking about before, a very, very strict power management scheme such that your battery can last for a day or two, right? The question is why this invention has not come to the infrastructure world. Because in infrastructure, somehow power was ignored, so to say, in last several generations, right? Somehow big bulky equipments with a lot of big power cable coming to them was somehow accepted. This is not going to work in the next generation that we are talking about in 5G, because the power consumption is getting like 10x, 100x more because of the capabilities that we have been talking about, right? And I want to mention that it's not only about TCO for the big macro cell, because yes, when you talk about big macro cell, it's total cost of ownership. We see a lot of customers coming to us, who want to kind of deploy 5G into enterprise or fixed wireless, where they don't want to run a power cable to the box, to the enterprise box, right? They just want the box to be powered over Ethernet. I'm talking about small cell deployments. The limit for power over Ethernet is 24 watts. Okay, in 24 watts, you got to run the whole 5G small cell. Right? So if you were to cater to those customers where they don't have the desire to run a power cable and an Ethernet cable to the box that you are deploying, you got to have tremendously low power consumption. Now, how do you do that? At EdgeQ, we basically bring a lot of these set principles that have been set in the UE world to the infrastructure world. Second thing is basically you got to control the baseband at a very granular level, right? Symbol level control is required. If some function is not required, like for example, when you are running a 4K FFT, maybe you can turn off your equalizer for 5 symbols. When you are running your equalizer, maybe you can turn off your decoder for few symbols. So these are the techniques that we employ in our silicon, where we basically tremendously bring down the power consumption be it a small cell configuration or be it a kind of a macro cell configuration in the configurable silicon that we are providing to the market.
Great. Well, thanks everyone. I just want to try and squeeze in a couple of quick questions before we end our discussion. Olivier, if I could just ask this one of you, who's calling for better silicon here? Is it the operators that's driving this change?
Yeah, if I'm a bit provocative, I could say that the most legitimate people are the ones who pay the electricity bill. And the way it is transferred inside the whole supply chain is that the operators put very strong requirement in terms of power efficiency, and also the way they buy the networks takes into account the power consumption. When we calculate, for instance, what we call the total cost of ownership, of course we include the power consumption. We think that it's a good thing also for social responsibility. It's a simple way also to kind of transfer this concern of power efficiency to the network manufacturer, whether or not we are in an open RAN context, by the way. But what is changing when we are in an open RAN context is that the operators are more directly, I would say, talking to the silicon vendors or board vendors or server vendors, because they are not anymore buying a fully integrated solution with its, let's say, typical power consumption. They also have the ability to work themselves on the integration and on how to optimize the full system based on the different subsystems. So I would say that I think we can say that the operators are leading this charge, but I think now that the whole ecosystem is conscious about this, which was not the case 5 or 6 years ago, but now I see really our partners following us in this concern.
Thank you. And Harpinder, as Olivier said, Open RAN is encouraging this increase in the ecosystem, in the supply chain, the diversity of choice. So, are you seeing operators be more proactive, I guess, in their choices of what they expect you to innovate on?
Right. So Olivier has pointed out to a very positive trend that we are seeing where ORAN and ORAN Alliance is enabling operators to talk directly with silicon vendors. So this didn't happen in the past. For 4G, silicon technology suppliers were directly talking to the infrastructure or system vendors only. And by having this ORAN Alliance open up a platform where operators can directly engage and talk to the broader ecosystem to influence the technology is a very positive change. So from that perspective, I think it is operators are having greater influence over the silicon technology that is being put together, including the boards. And also the specs which operators are putting together, silicon technology vendors are getting access to that, and they know exactly how they have to innovate and evolve their technology to address those requirements. Having said that, infrastructure vendors continue to be significant influencer for silicon technology development because they have to ultimately put together systems and service operators' requirements. And not just one operator requirement, they typically a system vendor will have to address tens or hundreds of operator requirements from one geography to another geography. And with this variation, they have to really make sure that they can manage their supply chain, they can manage the designs that they're putting together, because typically a bigger system vendor has to do more than 100 radios per year. So it's quite a daunting task. So they also put significant influence on how silicon technology is designed so that they can address requirements of different operators different use cases, as well as to future-proof their equipment, because the new use cases continue to come up, and particularly for 5G, we expect to see more new use cases to show up in coming years. So from that perspective, that we see that both operators and system vendors are influencing silicon technology. And given the fact that now silicon technology vendors have access to the operators and they understand their specs, they can also innovate technology to show new directions to the industry.
Very good to hear. Well, we are unfortunately out of time. We have to draw our discussion to a close, and we shall do so on that positive note. We definitely need to talk more about the role of Telecom Silicon, but for now though, thank you all very much for participating today and sharing your views with us. Now, if you're watching this on day 3 of our TelecomTV Summit on Open RAN, don't forget, send us any questions you have, and we'll try and answer them in our live after show program later today. And there's still time to take part in our online poll, which you can find below this video player window next to the Q&A app. All of this week's programs will be available to view online here at Telecom TV. We'll be back at the end of the day with the live after show, but until then, thanks for watching and goodbye.